So the other day we were talking about slope-intercept form. Slope-intercept form, y equals mx plus b. So if we have an equation solved for y, then the coefficient of x, the number next to the x, is the slope of the line. And then the plus b, that's our y-intercept. Remember, if they're subtracting, we can always add the opposite to make that easier for us to see what our y-intercept is. So if you look at problem 3, which equation represents the line shown? What we're going to be doing, looking at those equations, we're just going to look and see what the slope and y-intercepts of those lines are. Looking at our graph, what our slope and our y-intercept are. I'm going to start by just looking at the graph, and we'll just figure out what it's going to be here basically. So if we look at the graph, we can tell our y-intercept is good. So y-intercept, where it crosses the y-axis, is at -2. And then we can look at our slope. Slope is change in y over change in x. So we can see we're going up 2 and over 1. So our slope would be 2 over 1, which is 2. Okay. So our slope is 2, and our y-intercept is -2. Slope is 2, y-intercept is -2, matches with choice D. Okay, see that? Okay, good. If you look at the got it at the bottom of the page. Oh, one other thing just to mention back on problem 3. The first thing, if I'm just quickly looking at this problem, looking at the graph, we can tell our slope is positive or negative. Positive by the direction it's going. Okay, so automatically I'm eliminating which option? A. Good. So just by the slope, I know it's not going to be A. The y-intercept is -2, so it's not going to be B either by that. So it's down to either C or D just by quickly analyzing that. Alright, so if you look at the got it 3, what do you expect the slope of the line to be from looking at the graph? Positive or negative? Negative, right. Okay. And then part B asks actually what is the equation. So for what the equation is, we're going to start out, remember it's like y equals mx plus b. So for this one, probably the easiest thing to tell would be the y-intercept. So the y-intercept would be 2. Good. Okay, so we're going to have a +2 here. And then the only question is going to be what our slope is. So, like we said, our slope is going to be negative here. And we just pick a couple points on our graph. We can figure out what that slope is. So we go from one point to another point. We could go down down 1 and over 1. Or you could go down 2 and over 2. Okay? So down 1 over 1 means our slope is -1. So equation would be y equals -1x plus 2. If you just put y equals -x plus 2, that would be okay too. If we look at their part C, does the equation depend on the points you use? And the answer is no, because we have a straight line here. Our slope is the same. Okay, the steepness of the line doesn't change if I pick 2 points close together or further away. Like I said, we'd go down 1 over 1, we could go down 2 over 2. We could pick a point up here and down here. We could say 1, 2, 3, 4, down 4, and over 4. Okay, negative 4 over 4 still is negative 1. So there's not any magical 2 points that we have to pick in order to get the right slope for the problem. Another thing that we can be asked to do is to find an equation of a line that goes through 2 points. So in other words, they could give us the coordinates for 2 points, and they could say, find the equation of that line. In order to do that, the first thing we're going to do is take our 2 points and find the slope. We find the slope of the line, and then what we're going to do is substitute. We have our slope-intercept equation, y equals mx plus b. We're going to substitute the slope. We'll go in place of the m, and one of the points, which will go in place of the x and the y, and then that will leave us the y-intercept. The b will be the only variable left. We can figure out what that y-intercept is, and then we can go back using that information. We can write our equation. And it doesn't matter, I said using one of the points here. It doesn't matter which point you choose. Whichever point you choose, you'll actually get the same y-intercept, you'll get the same equation. So if we look at problem 4, this is the case we were just talking about. They're wanting us to write an equation in slope-intercept form that goes through the points 2, 1, and 5, negative 8. So first thing they did is they found the slope. I would have done this opposite, but that's okay. We did change in the y's, change in the x. Again, I like to start with the bigger y value, but however you do that, you work it out, divide it out, you get negative 3 for your slope. Once we get negative 3 for the slope, we're going to substitute in. So negative 3, they put in place of the m, and then they're just replacing one of the points. So one of the points we went through here was 2, 1. So they put a 2 in place of the x. They put a 1 in place of the y. They didn't really show the work here of what they did in between here to save space so you guys don't have like a 2,000 page book, 5,000 page book to carry around, whatever. But anyway, they would have multiplied negative 3 times 2, and then you add 6 on both sides. Then they would get the b equals 7. So y-intercept is 7. We know the slope was 3. So that's how they got the equation then, y equals negative 3x plus 7. And again, if we would have substituted the other point instead, if we would have substituted the 5, negative 8, we would have gotten the same y-intercept, the same equation. So if we look at the guide at 4, we want an equation of the line that passes through these 2 points. So like we said, our first step is to find our slope.
2 minus negative 3 over 3 minus 1.
Good. Okay, again, whatever y we start with, we have to start with the x. That's the same from the same coordinate there. Remember, subtracting, you can add the opposite on the top there would be
1.
And 3 minus 1.
2.
Okay, so we've got our slope is 1/2. Okay so far?
Mm-hmm.
Slope is 1/2. We know our slope-intercept form is y equals mx plus b. So we're just going to substitute some things in. So m, our slope is 1/2. We're just going to take one of those 2 points. So we can either take 3, negative 2 or 1, negative 3. Which one do you want to work with? 3, negative 2? Okay. There's not a definite advantage. Sometimes, if you have decimals on one, maybe you'll pick the other one. Or if you have negatives on one, maybe you pick the one that's positives. Again, if you label what the x and the y are here, just so we make sure we substitute it correctly, I would recommend you guys write the equation there, y equals mx plus b, just because then you're going to have the equation right there where it's going to be easy to see, okay, here's my x, which is 3. There's less of a chance of substituting the wrong number in, the x or the y, because that's a common mistake if we're not careful. The y is -2, and we're trying to find out what our y-intercept is. So it's just substituting slope and then one of your points, x and y. So then we're just going to simplify that. So 3 is like 3 over. Okay, so we multiply, would be 3/2, and then we would subtract. Now we know 3/2 is the same as 1.5, so if we subtract, we subtract 1.5, is going to be the same thing here, right? Okay, if you want to, over to the side here, we can work that out. Remember, add the opposite. So -2 plus -1.5 would be -3.5. Okay. If you wanted to, rather than changing the 3/2 to 1.5, we could have changed -2 to -4/2. Okay. And then the all-important step here at the end is that we actually substitute and say, here is my equation. So our slope was 1/2, and our y-intercept is -3.5. So you can either put plus -3.5 or minus 3.5. A lot of times, rather than -3.5, they will just put that as an improper fraction as -7/2. So either one of those would be fine for your equation. Another thing you might be asked to do is to graph a linear equation. So if they give us the equation of a line, they could say, what would this graph look like? So the first thing, if we graph an equation, we could start at the y-intercept and then use the slope to find another point on the line, starting from that y-intercept. So in other words, if our y-intercept is 2, we would start at the point 0, 2. Our slope was 1/2, let's say. From that point 0, 2, our slope is 1/2. We would go up 1 and over 2. That would be another point, and then we could draw a line that goes through those. Okay, and again, that third step, connecting the points and drawing arrows on the ends of the line. Another option you have, if you don't like this or if you forget how to do this part, another option is to just make a table of points. So like we've done before when we've graphed equations, we've graphed lines, we could put a 0, 1, and 2 in for x and then see what you get for y, and then just graph the line. It should make a straight line. If there's a fraction involved, multiples of the denominator. If you have y equals 1/3 x minus 2, we could do 0, 3, and 6 because our denominator was 3. Multiples of 3 there. Makes it easier so we don't have fractions to graph. We look at problem 5. It says, what is the graph of y equals 2x minus 1? So again, if you wanted to 2x minus 1, we can add the opposite here, make that plus -1 if you want. We need to see that -1 is our y-intercept. So that would be our starting point if we do it the way we just talked about. So they started out at -1, 0, -1, where that red dot is. And then the slope is 2, which is like 2 over what? 1. Okay. So remember, slope's changing y, we're changing x. So our slope's 2 over 1. Means from that y-intercept we go up 2 over 1. That gets them to the blue dot there. And then they just draw a line connecting the red dot and the blue dot, and they put arrows on the ends. And that's their equation. Again, if you don't like that way, if you don't want to remember as much stuff here, if you want to, you are welcome to just do a table. 0, 1, and 2. You put a 0 in, you get -1, which would be our y-intercept. You put a 1 in, you get 1, which is that blue point that they graphed. You put a 2 in, and you would get a 3, which is another point that that line goes through. Again, the nice thing with picking points like that, one advantage of doing that is that you're getting 3 points, and if you can get 3 points to line up, it's a pretty good chance that you've got the correct line. It's kind of a little bit riskier, you could argue, in some ways here, because we only have 2 points. We're picking the y-intercept, and then we're using the slope to find 1 point. So I can get any 2 points to line up. Okay, if I can get 3 points to line up, then that's saying something. So if you look at the got it 5a, if we go to graph this, again, first of all, we could start with our y-intercept here. So our y-intercept would be okay, 4 would be our y-intercept. Remember, it's y equals mx plus b. And the more times, as you guys do this stuff, the more you write that down or kind of remind yourself, m is the slope and b is the y-intercept in your equation. So we're going to start out at 0, 4. And then our slope would be
down 3.
okay, our slope is -3. Good, so we would go down 3 and over 1. When you graph it again, think about whether your slope looks like it's negative or positive. And you can draw a line through those points. And like I said, it's not a problem at all. If you would prefer, rather than doing it that way, your other option, there's no fractions here where you just put 0, 1, and 2. We'll get 0, 4, we'll get 1, 1, and we'll get 2, -2. You'd show your work off to the side on that. For example, if I put a 1 in, just go ahead and put something like this. Okay, the less stuff we do in our head, it's just a good habit to be in. Less chance of making a mistake there. We'll look at part B, similar idea. They want us to graph y equals 4x minus 8. So part B, if we start with our y-intercept, you can add the opposite here if you want. Our y-intercept is -8, which is going to be just off my chart here. Extended that just a little bit. And then our slope would be, which is the same as 4 over 1. Okay, so what that means, again, slope change in y over change in x. So slope is 4, means from our y-intercept we could go up 4 and over 1. Good. Up 4 over 1. 4 is a pretty steep slope. So it's going to look something like that. You can use, obviously I don't have the ability to do it on here, but you guys could use a ruler to make it to where you could draw a straight line going through those points. Other option again would be doing a chart. If you did a chart, you could have 0, -8, 1 would be -4, and 2 would be 0. 2, 0 there, actually we haven't talked much about yet at this point. That would be what's called the x-intercept. Again, that doesn't figure into our y equals mx plus b equation, but where it crosses the x-axis would be the x-intercept. Alright, over with problem 6. Talks about some real life situations here. If you're given a starting value or initial value, that's the same thing as our y-intercept, and then rate of change is the same thing as the slope. So problem 6, water pressure can be measured in atmospheres. Use the information in the diagram to write an equation that models the pressure Y at a depth of X meters, and what graph models the pressure. So first thing, looking at the picture here, you can see at 0 meters the pressure is 1 atmosphere. That would be like our y-intercept, that's our initial value. And then the pressure increases by 1/10 of an atmosphere per meter. That's our rate of change, or our slope. So from that, we can just substitute those into an equation here. That's how they got this equation. Y equals 1/10 x plus 1. And then the next thing is graphing the equation. So they graph this. Notice they have labeled this. They titled it pressure underwater. X-axis is the depth in meters. Y-axis is the pressure in atmospheres. We want to see the change in our pressure here. And you can see it starting out at 0, 1. And then you can see, notice on this one, since our slope was 1/10, that's like 1/10 as a fraction, basically they decided to go by tens here. If you were doing a chart, 0, 10, and 20 would be some good points, because those would be ones that you wouldn't have decimals to deal with. And so if we look at the got at 6, a plumber charges $65 fee for a repair plus $35 per hour. Write an equation to model the total cost Y of a repair that takes X hours, and what graph models the total costs. So equation for this would be Y equals 35x plus 65. It's $35 per hour, so that's our rate of change, which is our slope. That's how much it's changing by. Every hour it goes up $35. And then the $65 is initial fee. So sometimes, just for them showing up, there's a certain charge for that. And then after that point, then they charge an hourly rate. And then the graph, you could either use your y-intercept and your slope, or you could make a table here and find some points for that. Again, make sure you label your x-axis and y-axis. This time, just generally, the hours would be the x, the cost would be the y, and just kind of roughly sketching, our graph's going to be doing something like that, starting at 0.65 and then going up 35 over 1. So, again, I'm just roughly sketching this out, but 0.65, 1 would be 100, and then 2 would be 135. On the lesson check, if we look at number 4, it asks, is y equals 5 a linear equation? So y equals 5 is a little bit different look, because something's missing we normally see is the x. Okay, there's not an x there. What we could do, though, we could put the x in there. What number would we have to put in front of the x, though? A 0. Good. Because we take 0 times something, we're going to get 0. So y equals 0x plus 5. So this actually is a linear equation. We could just say that it's a linear equation with a slope of 0. What's going to happen there is this is going to be just a horizontal line, because y is always equal to 5. Kind of a weird one, where if you're doing a chart here, you put in a 0 for x, you get 5. You put a 1 in for x, you get 5. You put a 2 in for x, you get 5. We're going to get 5 no matter what. So it's a horizontal line. So that would be a linear equation. Back on page 308, it talked about a linear equation. It says an equation that models a linear function. So if we have a function, then we have a linear equation. So just one more little side note here on this one. If the equation, instead of y equals 5, if it was x equals 5, x equals 5 would actually be a vertical line. A vertical line is not a function, so that would not be a linear equation. So what we're going to do is on page 312, 7 through 21 odd, 22 through 35, 45 through 47, 58, and 62.